Hello, so in today's video, we're going to look at the next transformation in our videos of transformations. So in the previous video, we completed this transformation. We looked at this transformation, y equals a times f of x, and we saw that this was a stretch parallel to the to the y-axis by a scale factor of a. And we draw a sketch of that in there. So this time we're going to do the second transformation, y equals f of ax, where a is a bigger number than 0. So again, we've got a function like this, and we're now going to do this transformation y equals f of ax. We're substituting in ax into our function. So what will the transformation look like for this one? Okay, so we've got y equals f of a times x. So the key thing is that we've got, obviously here, this is our old graph. Let's just make a note of this so this is really clear. This is our old graph, y equals f of x. Now, instead of inputting x into our function, so the key thing is now we're inputting ax. We're inputting this ax number into our function, as we can see here. Yet we still get the same y coordinate. So y equals f of ax. Well, we're still getting the same y output there as the y outputs there. So let's think about this. Let's just take a random point on our curve, x old and y old. So this is a point on our y equals f of x graph, our original one. Okay, so if f of x old is equal to y old, but we still get the same y coordinate with this transformation ax. So that's telling us that our old y coordinate, this, must be equal to the function of a times our new x coordinate. So basically what we're saying is that we've got our original graph here. We substitute x old, which is this old x coordinate there. We get a y coordinate there, y old. Now, when we do a transformation, we get exactly the same old y coordinate. So that means that a times the new x coordinate, when we plug this into our exact same function, we get the old y coordinate. So that must mean that x old is equal to a times x new, the new x coordinate. So if we rearrange this, x old equals a times x new, divide both sides by a, we get that x new equals x old divided by a. So basically, the old x coordinate is the new x coordinate is basically a factor of a less than. So we divide the old coordinate by a to get the new x coordinate. So what does that mean? So let's say, I mean, for argument's sake, if a is about, let's just say that a is about 2, for example. So that means that the old x coordinates are being squished in by a factor of a. We're dividing it by a, so basically a factor of 1 over a. So let's just say, let's just say that here this is 1 over a there. Let's just say that this is minus 1 over a there. So basically, this coordinate is moving to here, being switched in. This one coordinate, value of 1 there on the x-axis, being moved to 1 over a there. So we're squishing in all of our coordinates by a factor of 1 over a. We're multiplying the x coordinates by 1 over a, so dividing by 1 over a. So what happens then is that we get, again, we're squishing this one in as well by a factor of 1 over a there. So what's happening is we're getting something like this. Something like this, where all of our coordinates, all of our x coordinates are being, again, multiplied by a factor of 1 over a. So this is our new sketch, y equals f of ax. So the key thing with this is that this transformation is a stretch again, but now parallel to the x-axis. So this is a stretch. I'll do this in green, actually. So this is a stretch parallel to the x-axis by a factor of 1 over a. Okay, so we're actually if a is positive, we're decreasing it. Well, actually, sorry, my bad. If a is bigger than 1, we're decreasing it. If a is between 0 and a half, we're actually making it bigger, because dividing by 1 over between 0 and 1. If you divide it by a fraction between 0 and 1, then obviously you're getting a bigger number. For example, 1 divided by a half is 2. So actually, if a was a half, you're actually going to stretch it outwards parallel to the x-axis. But in this case, it's going to be a stretch parallel to the x-axis with a scale factor. So scale factor 1 over a, regardless of whether a is between 0 and 1 or bigger than 1. And even if a was a negative, again, we'll come on to this in future videos, it's still the same theory. So you're multiplying you're dividing your old x coordinates on this f of x black line by a to get your new x coordinates. So you're squishing the graph inwards by a factor of 1 over a. That's kind of the idea of these graphs. So even if this is a 2 there, you're actually halving your x coordinates. If that was a half there, this a value, you're doubling your x coordinates. You're kind of doing the opposite of what you think. But the reason for that is because of this here, because our old y coordinate is the same as the function of our old x coordinate. But after a transformation, we still get the same y coordinates. So therefore, the new x coordinates must be the old ones divided by a. So that's why in this case, if a is bigger than 1, we squish it in. If a is between 0 and 1, with a magnitude between 0 and 1, we're actually stretching it outwards. But it's still a scale factor of 1 over a parallel to the x-axis. So that's that transformation.